Hello and welcome to the last video in the Python Decorators playlist. So in this video, we are going to cover parameterized decorators and class-based decorators. So till now, whatever the examples that we have gone through in previous videos, we have seen a couple of examples where there were decorators that were accepting parameters. For example, LRU cache. If you that was one of the classic examples that we have gone through. It accepted two parameters like max size and typed. If you don't know, you can watch just the previous video, like I think the third or fourth video in the series, third video I guess in the series, you will come to know about the LRU cache decorator. However, in this video we are going to explore how decorators accept parameters, or how to make decorators accept parameters. So a very basic thing that I would like to uh, invoke here is that you know that decorators accept the function that we are defining as parameters, as a parameter. They accept only one function as a parameter. So that what is that function? That is the function that we have defined. So they accept that function as a parameter. But there have been instances where we have seen that decorators can accept different parameters as well. How do we do that? So we do that, or Python do that, by creating a decorator factory that's essentially a function, and wrap the entire decorator within that function. If you can see in the screen, here there is this decorator factory that encloses this decorator inside it. This decorator construct is exactly what we have been seeing so far. So this is a decorator, it contains that inner function, and then finally it returns that inner function. However, this decorator factory is something that we are seeing first time. So we have encountered three nested functions. Till now we have been encountering only two. So the outermost decorator factory function accepts parameter, which is add to result set. What is that parameter? What we'll see that. But this decorator factory actually returns your decorator. So now what happens when you have this, when you want a decorator to accept parameter? Python invokes that decorator factory, which by passing those parameters that you want your decorator to accept. And now those parameters, one such, we are accepting one parameter here, which is add to result set. And this is on the top, this is present on the top level, the outermost function, which is that decorator factory, and will be available to all the inner functions and in the innermost function as well, because it has access to the local scope of the outer functions. It has access to this result set variable as well, and it can do what it has to do with that variable. So that's what I wanted to convey. So if you want to pass parameters to a decorator, if you want to pass arguments to your decorator and want your decorators to accept parameters, you have to you have to create an outer function, an outer layer of that function, a wrapper function that can accept those arguments, that can accept those parameters, and actually create and actually return a decorator in the end. So what Python does, Python invokes this decorator factory, returns the decorator, and then makes that decorator accept your function, which we have seen so far, and then that function will return this inner closure, and that closure will be executed when your function is invoked. So how that happens? Till now we have seen this is the function that we have, my func. Now this is the first first statement where actually Python, we are calling this decorator factory and passing that set add to result set this particular variable to accept false. I mean, I'm setting it to false by default, but I can remove it. So I'm setting this flag as false, add to result set, by passing false here. And then the decorator factory will return me the actual decorator. This decorator will be then invoked and passed my function to it. And then my function is going, and then this actual decorator is actually going to return the closure, that inner function. And this is pretty much this second statement here, line number 23, is pretty, we are pretty familiar with it. But this is something we are seeing for the first time. So when you have, till now, if you decorator was a syntactic sugar for such this kinds of these kinds of statements on line number 23. But the decorators accepting parameters, they are syntactic sugar to these two lines, include these two lines both, which means that if you are decorating this function with the decorator, which is called as decorator factory, and let that factory accept true, for example, I will remove these two statements. Then Python will, on our behalf, Python will execute these two statements. Python will first create that pass this decorator factory to whatever value we are passing, true here, for example, and then it will get the actual decorator, and then to actual decorator it will pass the my func, this function that we are decorating. This is our original function, and then it will return whatever it has to return, and that particular new function, the replacement of our original function, will be executed whenever our function is invoked. So I hope you've got this. So I'll just clear my terminal and execute this. So I have set it to true. So what happens? The inner function actually invokes this function, which is our function, uh, and it passes the arguments. So first pair of arguments that we have passed is 10, 20, which means our function just adds these two numbers and returns it. And this is where our function will be invoked. And it will return 10, 20, which is 30. Now 30 will be added to the result set if the flag that we had set here is true, which means the decorator factory we had sent true, which means this flag was set to true. Now, whenever our function is invoked, this inner function is executed. We have passed 10, 20. So 10, 20 will be passed to our actual function. It will return 30, and 30 will be added to result set because this flag is set to true. Again, we have we have passed 50, 50, which means when we invoke that function, this inner function gets executed, and 50, 50 will be added. 100 will be the result, and 100, since this flag is set to true, it will be added to the result set. Result set is actually a global list here, and then result set we are printing in the end. So that's what it contains. But let's say if we don't want to store the results in result set, we can set this to false. And when we execute this, our result is empty. So that's what the entire thing is. These parameters, you can think of them as a control parameters. And so, okay, decorators are meant to change the behavior of our function. They're meant to, most of the times they are meant to enhance the capabilities of our functions that we are using. But if we want them to change the approach, then we can have this decorator factory and pass some control parameters, and based on those control parameters it can decide what approach to take and what capabilities to add. That's the entire thing that these parameters do. So these parameters are based on which our decorators, or this inner function, it can behave in a certain way. These are very useful. For example, we saw that in cache decorator there was no parameter, so it it could actually grow the cache size to infinite if our function would run for infinite amount of time. For example, okay, mind you that if you haven't watched my previous video, I have covered cache and the LRU cache decorator. Please go ahead and watch the third video in the series, you will get to know what I'm talking about. And on the other hand, when LRU cache was passed that size parameter, you can set the maximum size of the cache. Then in the memory, even though your recursive function can run for maximum number of times, or any function that is going to hit multiple number of times for the size that you have set, the maximum limit that you have set by that parameter, it will only keep your memory to grow to that size only. It will not grow beyond it. So these are some examples. And however, this example that I've demonstrated here may not seem very, very relevant, and it is not very relevant, or it doesn't make much sense. But the thing is, I wanted to convey how you can pass parameters to the decorators, how you can pass arguments and make your decorators accept parameters. So this is how you have to create an outer decorator factory function, have it accept the parameters that you wanted to pass, and then use those parameters in your inner function, which will be executed when the original function will be invoked. So I hope it made sense till now. So let's move on with the another concept, which is class decorator. So in the class decorator, we have created a decorator factory using class. So this decorator factory has this constructor. So this constructor accepts the same parameter that we wanted to pass to the decorator factory, which means if you construct an object of this decorator factory, while constructing, you will have to pass that particular add to result set flag. It is exactly same function, behaves in the exactly same way as the previous example. So what we are doing here essentially is we are passing this flag will be set. Now once that decorator factory is executed, it is going to as we have seen in the previous example, it was returning us the actual decorator. Here it will be returning us the decorator factory object. Now when that decorator factory object is executed, this call method will be called. When that decorator factory object will be invoked, then this call method will be executed, and this call method will take our function and it will return this inner function. So this call method, you can think of it as the inner decorator function that we used to have till now. So you can treat this call method as the decorator function. So you can treat this as the decorator function. Okay, if you didn't get that, let me demonstrate that to you. What we are trying to do here is we want this decorator factory object and decorator factory. Let's say we are passing false, and we want to pass to this decorator factory object, we want to pass our function. So what we can do, decorator factory object pass my func, and to you can receive the returned response in my func itself. So these two are similar statements that we have seen in the previous example. Now if you execute this, because I've set it to false, the result set will not be we expect it not to get populated, because we if the result set will only get content only if this flag is set to true, but we are setting it as false by passing here. So this will be set to false. So let me execute this. So as you see that our result set is empty, but if I set it to true, then it contains 30. If you add more, if you want to add more values to it, we had added 50,50. So let's add 50,50 here as well. So we'll see that 30,100 is stored in the result set. What so we know that, okay, this is adding that decorator factory here as a decorator in form of a decorator is a syntactic sugar. So let's use that. It was just I had written that just to make you understand. So now if you write the same class based decorator as a decorator factory here, it works exactly in the same way. So once you execute it, it behaves this way. You can set it to false. Sorry, you can set it to false and execute it. The result set will be empty. Okay, so that's a very brief way in which I have explained you the class decorator. Probably function-based decorators are used more than class-based decorators, but class-based decorators has their own advantage. I hope you enjoyed everything that was covered in this decorator series, decorator playlist. I hope you like it. Please subscribe it, like it, share it, and I'll see you in the next one.